Hi, I am Sushma, working as Assistant Professor in the Department of EC in Institute of Aeronautical Engineering College. In this session, we are going to discuss about the binary arithmetic and complements, ones complements, twos complement, and R's and R minus 1 complements. So, in this session, we are going to discuss about the binary arithmetic, in that addition, subtraction, binary addition, binary subtraction, and ones complement, twos complement, and R's complement and R minus 1's complement, and some problems we will discuss on the complements. Binary arithmetic. So here in computer circuits do not process decimal numbers. They process only binary numbers. In our daily life, we will do additions and subtractions by using decimal, but computer or any digital systems will not understand the decimal number system. So it will do the operations such as addition, subtraction, multiplication and division in binary form only. So in binary operations, what are the operations we are going to discuss now? Only addition and subtraction. So here we have binary operations such as addition, subtraction, multiplication and division can be carried in binary arithmetic. So first we will discuss the binary addition. Here, before going to discuss about the binary addition, so just we have to know how to add the two numbers. Each numbers have one bit representation of binary. So if we have A is 0 and B is 0. Okay. So in binary addition, 0 plus 0. In binary, each digit can be represented by either 0 or 1. Okay. So if 0 plus 0, the result, the sum we will get is 0 and carry is 0. Sum is 0, carry is 0. Okay. If A is 0 and B is 1, that is 0 plus 1. If we want to perform 0 plus 1 in binary, so the sum will be 1 and carry will be 0. Sum will be 1 and carry is 0. If A is 1 and B is 0, A is 1, B is 0, 1 plus 0, the sum we are going to get is 1 and carry is 0. Okay, sum is 1, carry is 0. 1 plus 1, 1 plus 1. In binary representation, we have to remember this one, 1 plus 1 is either the output will be either 0 or 1. The sum will be 0 or 1. So 1 plus 1, the sum will be 0. The carry will be 1. If we add 1 plus 1, we will get sum is 0. The carry is 1. Okay. We should remember this one. Okay. 1 plus 1, the sum is 0 and carry is 1. 1 plus 1, the sum is 0 and the carry is 1. So, for binary addition, we know the basic two-digit addition 0 plus 0, 0 plus 1, 1 plus 0 and 1 plus 1. By using those addition, binary addition, here we are going to perform addition between 1, 0, 1, 0. The radix to represent it is a binary number system. Okay. 0, 0, 1, 1. Okay. Here 0 plus 1, we are going to perform addition here. Okay. 0 plus 1, it is 1. 1 plus 1, for 1 plus 1, sum is 0, carry is 1. So sum we have to write in the down and carry will be forward to the next stage. Okay. The carry will be forward to the next stage. So here we have 1 plus 0 plus 0. In the third step, we have 1 plus 0 plus 0. 1 plus 0, 1. 1 plus 0, 1. So here the sum is 1 and carry is 0. So the sum is 1, carry is 0. Okay. Now in last bit, MSB bit, we have 1 and in another digit we have 0. Okay. 1 plus 0, sum is 1. Carry is 0. So, sum is 1. We know If carry is 1, we have to write. If carry is 0, no need to write the carry here. So this is the binary addition of two binary numbers. For example, 28 plus 15 we have to perform in binary. So these numbers are in the decimal number system. We have to convert this into first into binary. Then we have to perform the addition. Okay. So how to convert the decimal number system into binary number system? So divide the number with the radix. Binary number system radix is 2. So divide 28 by 2. So 14. The remainder is 0. The quotient is 14. Again divide that quotient with the 2. 2 7 ja, remainder is 0. 2 3 ja, 6. The remainder is 1. 2 2 ja, 2 1 ja, 2. The remainder is 1. So here we got the 1. Okay. So write from down to up. 1 1 1 0 0. So 28 will be represented by decimal number represented by 1 1 1 0 0 in decimal. Okay. Again we have 15. So 2 7 ja, 14, remainder is 1, and 2 3 ja, remainder is 1, 2 1 ja, remainder is 1. So all ones. We know this one. 15 is represented by 15 in decimal is represented by all ones in the 4 ones in the binary form. So first write down the number representation of 28 in the binary number system is 1 1 0 0 0, and 15 is represented by 1 1 1 1. So first equal the numbers, the digits. So here we don't have MSB. Here we have 5 digits in 28 and 4 digits in 15. So here the MSB we can keep, here it is 0. Okay. So add these two numbers. 0 plus 1, 1. 0 plus 1, 1. 1 plus 1. The sum is 0. The carry is forward to the next stage. That is 1. Okay. Here, if you see this stage, we have 3 ones. We have to add 1 plus 1 plus 1. Okay. We know 1 plus 1 is equal. Sum is 1. Sum is 0. Carry is 1. That is 1 plus 1. Sum is 0. Carry is 1. Okay. Again we have to add 1 here. Okay. We have to add 3 ones. 1 plus 1 plus 1. So 0 plus 1 it is 1. And here carry is 1. So if we add 3 bits, 1 plus 1 plus 1, sum we are going to get 1 and carry also we are going to get is 1. Okay. So here 1 plus 1 plus 1, write down here, sum is 1, carry is also 1. The carry will be forward to the next stage. So 1 plus 1, MSB here, 1 plus 1, 0, sum, and carry is 1. Okay. So this is the output of 28 plus 15 in the binary number system. Okay. If you want to verify whether the answer is correct or not, just by observing this 8 plus 5, if 28 plus 15 is 43. So here the first LSB, the weight is 2 power 0. This is 2 power 1, 2 power 2, 2 power 3, 2 power 4 and 2 power 5. Okay. So 2 power 5 is 32 into 1 plus 0 into 2 power 4, 0 plus 2 power 3 is 8 into 1, 8. Weight the weight and the digit number. Okay. 8 plus 0 plus 1 into 2, 2 plus 2 power 0 is 1. 1 into 1, 1. So if we add all these things, you will get 43. Okay. So if you want to perform the binary addition, just we have to remember the single digits addition. Okay. 0 plus 0, sum is 0, carry is 0. 0 plus 1, sum is 1, carry is 0. 1 plus 0, sum is 1, carry is 0. Okay. 1 plus 1, the sum is 0, the carry is 1. Okay. If we remember this one, we can perform binary addition. It will be easy. Binary subtraction. Okay. So, suppose if you want to perform A minus B. A is a single digit binary number. B is single digit binary number here. Okay. So, A may be binary means either it may be 0 or 1. B either it may be 0 or 1. Okay. So, in first one, 0 minus 0. 0 minus 0. Here, in addition, we have sum and carry. In subtraction, we have difference and borrow. Okay. So, the difference between two digits is 0. The borrow is the whatever we are taking. If the larger number is subtracted from the smaller number, we will get the borrow. Okay. So, 0 minus 0. Here, the difference is 0 and borrow is also 0. Difference is 0 and borrow is also 0. 0 minus 1. 0 minus 1. 0 is smaller number. 1 is larger number. So, we are subtracting smaller number, larger number from the smaller number. So, here we are going to take the borrow. So, in that difference is 1. Borrow is also 1. We have to remember this one in the binary subtraction. Okay, 0 minus 1 is 1 difference and borrow is also 1. 1 minus 0. So, 1 difference, borrow is 0. 1 minus 0, the difference is 1 and borrow is 0. 1 minus 1, both are equal. So, difference is 0, borrow is 0. Difference is 0, borrow is 0. Okay. So, subtract. Here example is subtract 0, 1, 0, 1 from 1, 0, 1, 1, 2. So, from 1, 0, 1, 1, that is binary number. This radix indicate the binary number. We have to subtract 1, 0, 1, 1 from 0, 1, 0, 1. Okay. So, for a simple, if you want to perform binary subtraction here, we are doing subtraction here. For example, in decimal, I want to subtract 99 from the 100. Okay. This is decimal. Here the base is 10. So, here 0 minus 9. So, here we have to take borrow from 1. So, here we are going to get 10. Because this is decimal number system. So, from this we are going to get 10 and here we are going to get 10 minus 1, 9. Okay. But here in binary number system, the radix is 2. If we take the borrow from before digit, so we will get the 2 from there. And if we have any 0 in middle, here we will get 2 minus 1. Okay, how it will be, we will see here. So, in this 1 minus 1, the difference is 0. Okay, 1 minus 0, 1. Here, 0 minus 1. So, larger number is subtracting from the smaller number. So, we have to take borrow here. So, if we take borrow in the binary number system, here we will get 2, that is 1, 0. 2 will be represented in the binary number system, 1, 0. Okay, 2 minus 1, whenever we are going to get the borrow here, you have to make it 0. So, 2 minus 1, this is 1. Okay, this 1, 0 is nothing but 2. Okay, binary representation. So, that is 1, 1, 0. Okay, this is 13. 11 minus 5, you are going to get 6. 1, 1, 0 is 6. Okay. This is binary subtraction. So, representation of binary numbers. So binary numbers can be represented in signed and unsigned way. In our daily life, we will represent plus 3, minus 3, plus 10, minus 10. But the computers will not understand the negative numbers because the computation will be done in the binary number system. So here we have two types of binary number system: unsigned binary number system and signed binary number system. In unsigned representation, here we have only positive numbers. Okay, here we will represent only positive numbers. We don't have negative, represent negative numbers in the unsigned representation. Okay, whereas in signed number representation, the whatever the MSB bit, most significant bit. So the MSB bit represents the sign of the digit. Okay.
If it is 0, it is positive number. If it is 1, it is negative number.
Okay. So in signed representation, we have signed magnitude form, 1's complement form and 2's complement form. So we can represent these negative numbers and positive numbers in signed magnitude form, and the negative numbers are represented by 1's complement form and 2's complement form also. Okay. So unsigned numbers. So unsigned numbers don't have any sign. These can contain only magnitude of the number. So if we want to represent 50 in binary, so how we will represent? Just only 111. Okay. 9 I have to represent 1001. Here we don't have any special digit for the sign. Only positive values will be represented in the unsigned number system. Okay. Since there is no sign bit, in this unsigned binary number. So n bit binary number represents its magnitude only. Here we don't have any special digit for the signed representation in unsigned number system. Okay. 0 is also unsigned number. This representation only have 10, which is always positive. Here 0 also we can represent if it is a 4-digit 0. We don't have plus 0, minus 0. We can't represent in the unsigned number system. Only the magnitude will be represented here. Every number in unsigned number representation has only one unique binary equivalent form. The range of unsigned binary number is from 0 to 2 to the power of n minus 1. Okay. Represent decimal number 92 in unsigned binary number. So here we have to represent the 92. 92 in binary number system. How we can represent? So here 2 power 0, 2 power, the weights of the binary number system are 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6. Okay. If we perform 0, 0, 2, 12, 0, 2, 6, 92. Here 2 4 ja 8 and 2 6. The remainder is 0. And here 2 23 0. 2 1 ja 2 11 ja 22. Remainder is 1. 2 5 ja 10. Remainder is 1. 2 2 ja 4. Remainder is 1. 2 1 ja 1. Remainder is 0. So from down to up, write down the value 1 0 1 1 1. So 1 1 1 0 0. Okay. So here that will be represented as 1 0 1 1 1 0 0. So 2 power 0 1 2 3 4 5 6. So each digit will be represented by 1 0 1 1 1 0 0. Okay. So find the range of 5-bit unsigned binary numbers. Also find minimum and maximum value of in this range. So here we are taking 5-bit number. So here n is equal 5. What is the range of unsigned bit number? Here it is 0 to 2 to the power of n minus 1. So that is 0 to 2 to the power of 5 minus 1. Okay, so the range is from 0 to 2 to the power of 5 minus 1. So 5 digit means from 0, 0, 0, 0 to 5 zeros to 5 ones. Okay. Signed numbers. Signed numbers contain sign flag. This representation distinguish positive and negative numbers. So here in signed numbers, we can represent digit by sign value and unsigned value. So we can represent plus or minus of the number. Okay. So this technique contains both sign bit and magnitude of a number. So in this, if we represent a number in binary form, the most significant bit is for the sign bit. The most significant bit is for the sign bit. The remaining bits are magnitude. The remaining bits represents the magnitude of the number. So representation of signed binary numbers, there are 3 types of representation for signed binary numbers. Because of extra sign bit, binary number 0 has 2 representation. Either positive for 0, negative for 1. So here if the value of sign bit is 0, then given number will be positive. Else if the value of sign bit is 1, then the given number will be negative. So remaining n minus 1 bits representation magnitudes of the number. Okay. So if the value of the MSB bit is 0, then that number is positive number. If it is 1, then that number is negative number. See here, if it is, we are representing a 8-bit signed number here. Okay, B0, B1, B2, B3, B4, B5, B6 and B7. So here, this is called as MSB bit and this called as LSB bit. In signed numbers, the MSB bit, most significant bit, represents the sign bit. Okay. If it is positive, then the MSB is 0. If it is negative, the MSB is 1. Here, MSB plus 24 is represented. This is the magnitude and the MSB bit is sign bit. So here, plus 6 we have to represent in 8-bit number. Okay. So here, we know 6 is represented by 110. But we have to represent that in the 8 bits. Okay. In that 8 bits, 7 bits are for magnitude. That is, it represents 6 value. The 8th bit, that is MSB bit, represents the sign. So here we have to represent plus symbol. Plus represents 0. So the MSB bit is 0. For example, we want to represent minus 6 in signed numbers. So the magnitude is same, 1, 1, 1, 0, 0, 0, 0. So this is 6. The MSB bit is minus. We have to represent negative number. So that is the MSB bit is 1. Okay. In signed numbers, the MSB bit represents the sign bit, whether it is positive or negative. If it is 0, then it is positive number. 1, it is negative number. Complements. So here, why we are going for complements? Okay. If we subtract any number, so we want to subtract 8 from 5. Okay. Here if we want to subtract 8 from 5, see here 0 minus 1. So here we have to take the borrow. So we are taking borrow from here. It is 2. That is because it is a binary number system. So 2 minus 1, it is 1. 1 minus 1, 0. 1 minus 1, 0. Okay. So that is 3. So 8 minus 5, we are doing 3. So here by taking borrow, it is looking some complicated. Okay. To simplify this subtraction, okay, we are going for complements. Okay. Complements are used to simplify the subtraction operation and for logical manipulation. Okay. Here we have radix complement and diminished radix complement. Okay, so we have r's complement. Diminished radix is nothing but r minus 1's complement system. For example, for binary system, the radix is 2. Okay, the subtraction we can perform either by using 2's complement, and diminished radix method is 2 minus 1, that is 1's complement. Okay, for octal system, the r is equal to 8. So for r is equal to 8, we have r's complement. We can perform subtraction using 8's complement, or 8 minus 1 is 7's complement. Diminished radix complement is r minus 1, that is 8 minus 1 is 7's complement. Okay, next. For decimal system, the radix is 10. For the decimal system, radix is 10. So we can perform subtraction using 10's complement, or 10 minus 1. Diminished radix is r minus 1. So here that is 9's complement. For hexadecimal, r is equal to 16. The base is radix is 16. So here we can perform 16 complement, the subtraction, and by using 15's complement. Okay. So here we will discuss the r's and r minus 1, that is diminished radix complement method for subtractions. So before going to that one, we will see what is 1's complement, 2's complement, 9's, 10's complement. Then we will do some subtractions. So here what is 1's complement? 1's complement of a binary number that results when all 1's become zeros and zeros becomes 1. For example, I have 1 0 0. So what is 1's complement of 1 0 0? So 1 will become, this bit will become, 1 will become 0, 0 will become 1, and this 0 will become 1. Just complement of the number, each digit. Okay. So 1 0 0, 1 become 0, 0 become 1, 0 become 1. Okay. So this is 1's complement. So find 1's complement of 1 1 0 1. So 1 1 0 1. 1's complement is 1 becomes 0, 0 become 1, 0 0. Okay. So find 1's complement of this number. Okay. Here 1 becomes 0, 0 1, 0 become 1, 1 0, 0 0, this 0 became 1, 1 is 0. So here the 1's complement of this number is 0 1, 0 0 0 1 1 0. Okay. 2's complement of binary number. So here the 2's complement is nothing but 1's complement plus 1. The result when add 1 to the 1's complement is 2's complement. Here first we have to perform the 1's complement of the number and add 1 to the LSB. Okay. Then you will get the 2's complement number. For example, we were to perform 2's complement of 1 1 0 1. So 1 1 0 1. First we have to know the 1's complement of that number. Then add 1 to that result. Then you will get the 2's complement. So 1's complement of 1 1 0 1 is 1 will become 0 0 1 0. And we have to add 1 to the LSB. Then it will be 2's complement. So 1 1 0 0. This is 2's complement of 1 1 0 1. Okay. So here the 2's complement of this number. First we have to perform 1's complement. So what is 1's complement of this number? 1 will become 0, 0 will become 1. So just complement of each digit. So 0 1 0 0 0 1, 1, 0. 1's complement plus 1 is 2's complement. So 0 plus 1 is 1, 1, 1, 0, 0, 0, 1, 0. This is 2's complement of this number. Okay. Subtraction of smaller number from larger. So here we have to perform 1's complement subtraction. So subtraction of smaller number. Here we have two types of subtractions here. If we performing subtraction of smaller number from the larger number and subtraction of larger number from the smaller number. Suppose if we want to perform A minus B. Okay. If A greater than B, first one. Second one, we are performing A minus B where A less than B by using 1's complement method. So here the procedure for the 1's complement subtraction, here determine 1's complement of the smaller number. Suppose I want to perform 7 minus 4. 7 is represented by 1, 1, 1 and 4 is represented by 1, 0, 0. Okay. So 7 is, here we are performing subtraction smaller number from the larger number. So further the first step is determine 1's complement of smaller number. So what is smaller number here? 1, 0, 0. So perform 1's complement of 4. So 4 is represented by 1, 0, 0. So perform 1's complement. So 0, 1, 1. Okay. Add the 1's complement to the larger number. So larger number is here 1, 1, 1, 7 and 1's complement of 4, that is 0, 1, 1. Okay, we have to add 1 plus 1, 0, the carry forward to the next stage. 1, 1, 1, it is 1, the carry is forward to the next stage. 1 plus 1, 0, 1. Okay, here we are getting extra carry here. Okay, if we get the carry, remove the carry and add it to the result. So this carry will be added to the LSB. So 0, 1, 0 plus 1, that is 0, 1, 1. That is representation is 3. So 7 minus 4 we are going to get 3. So this is the procedure for 1's complement subtraction. Just first what we are doing, we are subtracting smaller number from the larger number. For the first step 1 we have to find out the 1's complement of smaller number and add 1's complement to the larger number. So here 1, 0, 0, 1, 1's complement is 0, 0, 1. In step 2, what we have to do? We have to add this result to the larger number, that is 1, 1, 1, 0, 1, 1. Okay. So we have to perform 0, 1, 1, 1, 0, 1. We are getting carry. In step 3, add this carry to the LSB. So 0, 1, 0 plus 1. So 0, 1, 1. That is 3. So 7 minus 4 we are getting 3. Okay. So subtract the following using 1's complement method. Step 1 what we have to do? So we have to perform here 1, 1, 0, 1 minus 1, 0, 0, 1. Okay. So 13, this is 9. We are subtracting smaller number from the larger number. So first step 1 what we have to do? We have to find out the 1's complement of the smaller number. So find out the 1's complement. So here 1's complement is 0, 1, 1, 0. So 1 becomes 0, 0 becomes 1, 1 and 0. So 0, 1, 1, 0. In step 2, we have to add this result to the larger number, that is 1, 1, 0, 1, 0, 1, 1, 1, 1, 0. So 1 plus 0, 1. Here we have to perform addition. 1. 1 plus 1, sum is 0, carry forward to the next stage. 1 plus 1, 0. The carry we are going to get is 1. So in step 3, add this carry, we have to add this carry to the LSB. So 0, 0, 1, 1 and this carry add to the LSB. So 1 plus 1, 0. Some carries forward to the next stage. 1 plus 1, 0. The carries forward to the next stage. 1, 0. So this is 4. So 13 minus 9, we are getting 4. Okay. This is the procedure for ones complement subtraction for smaller number to larger number. So here we are going to discuss the ones complement subtraction from larger from the smaller. Okay. That is 4 minus 7. Okay. We are subtracting larger number from the smaller number. Okay. In this same procedure, only the last step will be changed here. Determine ones complement of the larger number. Add ones complement to the smaller number. So take this ones complement and add to this one. You will get some result. So take ones complement of the result and assign negative value. Again we have to find out the ones complement and give negative sign here. Okay. So for example, first we will discuss 4 minus 7 small digits. Then you will understand for the larger number. So 4 minus 7. 4 is 1, 0, 0. 7 is 1, 1, 1. Okay. So here we are subtracting larger number from the smaller number. So first we have to find out the ones complement of 7. So that is 0, 0, 0. Okay. Here add this 0, 0, 0 to the 4. So 0, 0, 1 we are going to get. Then again we have to take ones complement of the result. So 1, 0, 0, ones complement is 0, 1, 1. And assign negative sign here. So this is 3. Assign the negative sign to the total result. So that is minus 3. So 4 minus 7 we are going to get minus 3. So here also subtract the following using ones complement. So we are 1, 1, 1, 0, 0, 1. From 1, 0, 1, 0, 1, 1. Okay. So first to find out the ones complement of this one. So 1, 1, 1, 0, 0, 1 ones complement is 0, 0, 0, 1, 1, 0. Okay. Add this ones complement to the minus hand. 1, 1. Then 1, 0, 1. 1, 0, 1, 0, 1, 1, 1. Okay. Then, after adding these two numbers, again perform ones complement of the result. So, here you are going to get 0, 1, 1, 1, 0, 0. Assign negative sign to this number. This is the ones complement subtraction method. So, 2's complement subtraction here. Subtract a smaller number from larger number. Same procedure like ones complement. Okay. Here we have to subtract a smaller number from larger number. Subtraction of larger number from smaller number. So, the procedure for the determine the 2's complement of the smaller number. Here we are subtracting smaller number from the larger number by using 2's complement method. Before we discussed about the ones complement subtraction, here we are doing subtraction by using 2's complement method. Here in 2's complement method, first step we have to determine the 2's complement of the smaller number, add the 2's complement to the larger number, discard the carry. So suppose here we have 1, 1, 1, 4 is 1, 0, 0. So we have to perform subtraction here. But in 2's complement, first step we have to find out the 2's complement of the subtrahend. So here 1, 0, 0's 2's complement is 1's complement plus 1. So 1's complement is 0, 0, 1, 1 plus 1. That is 1, 0, 0. Okay. And add this 1, 0, 0 to the 7. So 1, 1, 1 plus 1, 0, 0. So 1, 1, 0, 1. Okay, discard the carry and we have the carry here 1. In 1's complement, we add this carry to the LSB. In 2's complement, we have to discard this carry and write down this number. 0, 1, 1 is 3. We got the answer 3. So here subtract the following using 2's complement method. So from 1, 1, 1, 0, 0, 1, 1, 0, 1, 0, 1, 1. Okay. So we have to subtract this one. First find out the 2's complement of subtrahend. That is 1, 0, 1, 0, 1, 1. So that is 2's complement is 1's complement plus 1. So first 1's complement is 0, 1, 0, 1, 0, 0 plus 1. That is 1, 0, 1, 0, 1, 0. This is 2's complement of this number. And add this to the minus hand. That is 1, 1, 1, 0, 0, 1. That is 0, 1, 1, 1, 0, 1, 0, 1, 0, carry 1, 0, 1. Here we have carry 1. So discard this carry and the result is only 0, 0, 1, 1, 1, 0. Okay. This is the 2's complement method. Two's complement subtraction larger from the smaller, that is 4 minus 7. So we have to subtract larger number from the smaller number. The procedure is determine the 2's complement of the larger number, add the 2's complement to the smaller number, take 2's complement of the result and assign negative value. So here from 1, 0, 1, 0, 1, 1, we have to perform 1, 1, 1, 0, 0, 1. Okay, find out the 2's complement of subtrahend here. So here 1, 1, 1, 0, 1 is 1's complement plus 1. So 1's complement is 0, 0, 0, 1, 1, 0 plus 1. That is 0, 0, 0, 1, 1, 1. Okay, 2's complement method. So add this value to the minus hand. That is 1, 0, 1, 0, 1, 1 and plus 2's complement of this number is 0, 0, 0, 1, 1, 1. So 0, sum carries 1, sum is 1, carry is 1, sum is 0, carry is 1, 1 plus 1, sum is 0, carry 1, 1, 1. Again we have to take the 2's complement of this number. Okay. So 2's complement of this number is 1's complement plus 1. So 1's complement is here 0, 0, 1, 1, 0, 1 plus 1. So 0, 1, 1, 1, 0, 0 and assign negative value to this number. Okay, this is minus 0, 0, 1, 1, 1, 0. So first we have to take the 2's complement of subtrahend, add to the minus hand, then again perform 2's complement to the result, assign negative value to the result. So these are the 3 steps to perform the 2's complement subtraction, that is larger from the smaller number. Okay. Here R's complement. So here it is easy to do 1's complement and 2's complement. But if we for the octal, the radix is 8. So we can perform subtraction by either using diminished radix method is r minus 1, that is 7's complement and 8 complement. For decimal, 9's complement and 10's complement. For hexadecimal, 15's complement and 16's complement. So to perform all this, if we want to suppose to base 4, the subtraction can be performed by 3's complements or 4's complement. So for general radix are how to perform the subtraction and what is r's complement. So the r's complement of non-zero number in any number system with base r can be calculated by adding 1 to the LSB of its r minus 1's complement. That is nothing but r's complement is equal r minus 1's complement plus 1. Okay. So how to perform this r minus 1's complement? For example, in octal system, okay, the base r is equal to 8. Okay, r minus 1 is equal 7. So each digit in the octal system we should subtract by r minus 1. That is nothing but, suppose I have 123 in octal. Okay, to perform r minus 1's complement, each digit should be subtracted by r minus 1. R is here 8. The radix is 8. So r minus 1 is 7. So each digit will be subtracted by 7. Then you will get this is r minus 1's complement. If you add 1 to this one, you will get the r's complement. That is 8's complement. Okay, if it is hexadecimal number, r's complement is 15's complement plus 1. Okay, 8's complement is 7's complement plus 1. So how you will get 7 complement? Each digit of that octal number should be subtracted from the 7. Each digit, total number, each digit should be subtracted from the 7. To find the 15's complement, each digit of the hexadecimal number should be subtracted from the 15. You will get the 15's complement. So similarly, in octal number system, 8 complement of 347 can be calculated by adding 1 to the LSB of its 7's complement. So 7's complement of 437 is 430. How? 437. So 7's complement, how we have to perform? Each digit should be subtracted from the 7. So 7 minus 7, 0. 7 minus 4, 3. 7 minus 3, 4. So we got 7's complement is 430. To find the 8 complement, we should add plus 1 to the LSB. So plus 1, that is 431 in the octal. 431 in the octal. So already we discussed the 1's complement, 2's complement here. 9's complement. It is the subtraction of decimal number can be accomplished by the 9's complement and 10's complement. If it is a decimal number subtraction, then we can subtract by using 10's complement and 9's complement. So 9's complement of a decimal number is obtained by subtracting each digit of the decimal number from 9. Okay. Suppose I have 543 in decimal. How to find out the 9's complement of this one? Each digit should be subtracted from 9. So 3 should subtract it from 9, 4 should subtract it from 9 and 5 should subtract it from 9. So 999 minus 543. So 654. This is 9's complement of 543. Okay. So to get the 10's complement of this number, we should add plus 1. Okay. So 457 of 10 is 10's complement of 543. Okay. So here example 2457, we have to find out the 9's complement. So each digit will be subtracted from 9 and you will get the result is 7542. If from the 10's complement add 1 to this result, then we will get the 10's complement. So subtraction using r minus 1's complement here. So the same rules apply to subtraction using the r minus 1 complement. The only difference is that when an end carry is generated, if the carry is, this is A, this is B, any radix. Okay. So here by using r minus 1's complement, after subtracting this one, if carry is generated, it is not discarded but added to the least significant bit. Added to the least significant bit. Okay. If no end carry is generated, then the answer is we have to discard that no carry is generated. Then we have to add negative symbol and perform r minus 1's complement to the result and add negative symbol. Same as 2's complement only. What we will do in 2's complement? Just we will find out the 2's complement, and if carry is generated, then add it to the 1's complement. So for 2 binary system, we will get R minus diminished complement is 1's complement. So if carry is generated, add to the LSB and find out the 1's complement and add negative. If the no carry is there, find out the 1's complement and give negative sign to that one. Okay. So here these are the examples of R minus 1's complement. For example, for R minus 1's complement, I am taking 15's complement subtraction here. So here in 15 complement subtraction, I am subtracting B02 from 98F. Both are hexadecimal numbers. Okay. So first what we have to do? First we have to find out the 15's complement of this number. Okay. What is step 1? 15's complement is of 985 we have to find out. Okay. So in that first we have to subtract each digit with the 15. Okay. 15 minus F, that this is 7. Okay, 15 minus 7 here. So for 15 minus 7, what we have to do? It is 6. Here I am going to perform 15's complement. So I am going to subtract B02 minus 9F. Both are in hexadecimal numbers. So I have to perform this one. In step 1, what we have to do? First to find out the 15's complement of 98F. So how we have to perform 15's complement? Subtract each digit with the 15. So F is nothing but, first for subtraction, F is represented as 15. 15 minus 15, 0. 15 minus 8, 7. 15 minus 9, 6, 7, 0. Okay, add this in step 2. Add this result to the minus hand, that is B0, 2 plus 6, 7, 0. 2 plus 0 is 2, 7 plus 0 is 7. B C plus 6. B plus 6 is after B, C, D, E, F, 1, 0, 1, 1 we are going to get. So the carry we are going to get is 1 here. Okay, here we are getting 1. See here, if carry is generated, if n carry is generated, what we have to do? We have to add that to the least significant bit. So add that carry to, in step 3, add this carry to LSB. So 173 is answer. Okay. So if carry is not generated means what we have to do? We have to perform what we have to do. We larger number from the smaller number. We will not get any carry. During that time, we have to find out the 15's complement of that number and add negative sign to the result. So for R's complement. For R's complement, here make the minus hand and subtrahend equal by adding 0. Suppose I have 1, 0, 0, 1 and minus hand. A, B is 0, 1 only. So by adding zeros at the MSB side, make the equal length of A and B. Find R's complement of subtrahend and add minus hand to the R's complement of subtrahend. If the sum produces carry, then discard it. If the sum doesn't produce carry, then R's complement of the result and please add the negative sign in front of it. So for already we perform the 2's complement. R is equal to base. So that is R's complement is 2's complement. What we did in 2's complement? In 2's complement, if A minus B we have to perform here. So find out the 2's complement of B and add it to the A Okay, if carry is generated, discard it, the remaining bits will be the result. If carry is not generated, if the carry is no carry is generated, then find the 2's complement of the result and keep negative sign to the result of 2's complement. Okay, so this is R's complement procedure. So if we base may be anything, it may be octal, decimal or hexadecimal, or if we base is 4 also, by using these steps we can perform the subtraction by using R's complement method. Okay, so in our R's complement method, so here already we discussed the 1101 binary number. So we will take another example. R's complement is binary, so 2's complement only. Already we discussed the 2's complement subtraction. Just to perform 16's complement subtraction of CB2 minus 972. Okay, so here to perform this, both are in the hexadecimal number. To perform the hexadecimal subtraction, what we have to do? First we have to find out the 16's complement of this number. Okay, how we will get the 16's complement is 15's complement plus 1. Okay, so how we will get the 15's complement of this 972? So each digit should subtract from 15. So 972. Okay, so 15 minus 2. 15 is F. Okay, minus 2. So that is ED. So you will get D. 15 minus 7, 6. 15 minus 9. This is 8. 15 minus 9 is 6. Okay, so here add this result to the minor head. That is in step 2, CB2 plus 68D. Okay, D plus, again sorry, here we have to perform 16 complements. We got it is 15's complement only. By adding 1 to the MSB, we will get the 16's complement. So this is E8, 6. So this is 16 complement. 16 complement is 15's complement plus 1. Okay, so add this result to the minor head. That is step 2. In step 2, CB2. So minor head is CB2. Add the 16's complement to the CB2. Here you will get, that is here E plus 2. E after F and 0, 1 0. So 0, 1. B plus 1 plus 8, that you will get it is 4. And C plus 6 it is 3. Okay, you are going to get a carry 1. What is R's complement result? If the carry is generated, if the sum produces carry, then discard it. If sum doesn't produce the carry, we have to take the R's complement. So here we got the carry is 1. So discard it. The result is 340. So CB2 minus 972 is 340. Okay. For example, A is 16 and B is a hexadecimal number. B is the larger number. A is compared with A. So here first we have to find out the 16's complement of B. If suppose I get that is C. Okay. Then add A plus C. Okay. Then you will get the result. If no carry is generated in this situation, then find out the 16's complement of this result. Okay. And add negative sign to that result. Then that is the R's complement method. Okay. So here the main diagrams are taken from the javapine.com, and the problems are mostly taken from the Modern Digital Electronics book and Digital Design Principles and Practices book. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.